Okay, so on the syllabus it says I'm going to be talking to you guys about percent yield, but I lied. I did that in class. And instead I'm going to move us quickly ahead to the concept of the limiting reactant. Now, this can be something that is tricky unless you sort of remember this metaphor that I'm going to be talking about. And that is the concept of dressing me up. All right, so what you see here, oh, well, I left out underwear. Just imagine I do wear underwear though. But you see a complete Changian outfit going on here. And let's imagine that I can only always have a certain combination of things. All right, so I can only have my red shirt, my one red shirt, go with my one pair of purple pants, with my one pair of pink socks, my one pair of black shoes, my one white shirt, and my one red polka dotted necktie. So these things always have to have this combination. You have to have all of these things. Now, if I wanted to know how many outfits I had hanging in my closet, and I had, let's say, let me go back to my black marker here. Hold on just a second. Let's say I had 22 shirts. I had 8 pairs of pants. I had 13 ties. I had 4 vests. I had 18 pairs of shoes. And I had 700 pairs of socks. Okay? And I wanted to know how many outfits I could actually lay out on my bed that would be complete outfits. Now, obviously, when you take a look at this, I hope you can see that the thing that's really going to limit the number of outfits is the smallest number of the items that I have here. And if I always have to have at least one sweater vest, then the most I could do here with my 4 sweater vests is have 4 outfits laying out on my bed. Everyone understand that? So in that way, my sweater vests are my limiting reactant in the reaction of creating the different combinations of outfits that I can actually have. Well, that's exactly what we're going to do in chemistry. When we combine things, to this point we've always talked about, in some ways, having an unlimited number of reactants. We really haven't cared about which one was limiting because we always just assumed that we had enough on hand. But in reality, there's always going to be one reactant that limits the reaction, that determines how much of a given product you're going to create based on that limiting reactant. So, what does this mean? Let's take a look at a reaction just so we can be more clear how this applies to chemistry. Okay, so here we have an equation for the formation of water. Now, of course, we do have to balance this up here, so I'm going to put a 2 here and a 2 here, which will allow us to have our fully balanced equation. What we're talking about in terms of limiting reactants is, imagine the situation. Imagine that I have 1.22 grams of oxygen, and I have 1.05 grams of hydrogen. Now you might think to yourself, upon looking at this equation pretty quickly in the numbers I've given you, that, oh, well, hydrogen must be the limiting reactant because there's less of it in terms of grams. But don't forget, reactions are all about moles and ultimately combining atoms. And in this case, you need to have 2 molecules of hydrogen gas to every 1 molecule of oxygen gas. Not only that, hydrogen is quite a bit lighter than oxygen. A single atom of oxygen is 15.9994 grams per mole, whereas a single atom of hydrogen is 1.00794. I'm not even sure what it is off the top of my head, actually. So it's much tinier, right? It's essentially a 1/16 of the mass of oxygen. So you can't know just by looking at the number of grams. You have to go by the number of moles. So let's see how we would approach this problem. All right, so what do we do with these numbers? Well, remember how I said that if you don't do a mole conversion as one of the first things you're going to do, then you probably are sunk. the first thing you need to do is create the balanced equation. So the second thing you do is the mole conversion. So we're going to take our 1.22 grams of oxygen, and we know that 1 mole of oxygen is equivalent to 31.9988 grams of oxygen. Now, where did I get that information? That's because O2, I know if I consult my periodic table, one atom of oxygen is 15.9994 grams per mole, but I have 2 of them because it's O2, which is 31.9988 grams. So there I have my molar mass for O2, and when I put this into my calculator, I generate 0.038126 moles of oxygen. So that's the number of moles of oxygen that are in 1.22 grams of oxygen. So let's do the exact same thing, but this time we're going to do it for our hydrogen. So I take my 1.05 grams of H2, I use a similar equivalency, and in this case it's 2 times 1.00794, because that's the molar mass of a single hydrogen atom, but we have H2 on our hands. So that gives us 2.01588 grams of H2 gas, and when I put this into the calculator, I get 0.52086 moles of hydrogen gas. And now I know how much we have in terms of the moles of each one of these 2 gases that are going to be involved in my reaction. Now what we need to do is figure out which one is the limiting reactant. And we need to go back here to our equation in order to solve this. So if we assume for a moment here that we actually are going to just arbitrarily pick one, let's go with our oxygen. And we know that 1 mole of oxygen with an unlimited amount of hydrogen gas, and we do have to assume that for just this moment. Okay, so we have, what is it? We had 0.038126 moles of oxygen. How many moles of water will that produce? Well, this then becomes a relatively easy ratio problem, because we can see here that for every 1 mole of oxygen we have 2 moles of hydrogen. But we don't have 1 mole, we have this number of moles of oxygen, so we obviously need to do an equivalency. My favorite thing, even though you could probably do this in your head, I like to do it completely out so that you know exactly how to do this problem later on. So that's my, I'm not leaving myself enough room here. Here, I'm going to move this. Lumpy, do you need help? I'm doing a screen. You know, I decided I'm going to do my screencasts here. Yeah. So is that okay? All right, get out of here.
But I need a bump.
Well, tough it. I can't do it right now. I'm doing a screencast, you bum.
Fine, when you finish?
Yeah, we'll probably be able to go out. All right, now get out of here. Unless you know how to do these problems, then you can explain it to the kids. All right, so I have this number of moles of oxygen, and my equivalency is that I have 2 moles of water for every 1 mole of oxygen gas. How did I get that? Because I looked right here. I have a 1 here, and I have a 2 right there. Now, I'm going to actually erase that 1 because it now looks like Oh, Chang, stop that. I'm going to do a nicer job of erasing that 1. There we go, and that underline there. All right, so, didn't take it off the erase mark. Whoops. So when I stick this into my calculator, I get 0.076252 moles of water. I'm going to circle this up in purple because this is going to be an important thing that I'm going to use to compare to my next problem that I'm going to do, which is, what if I had the opposite? And instead, let's say I start off with 1.05 grams of hydrogen gas and unlimited oxygen. So if that were the case, now I need to go to my hydrogen. I know that I have 0.52086 moles of hydrogen gas. And so you can see, let me erase these stray marks here. You can see that if that's my mole number here, I'm going to take my 0.52086 moles of H2 gas, and I'm going to do an equivalency again. But this time my equivalency is going to be with H2 gas, and I know that if you go back up here, I have 2 moles of H2 gas and 2 mole to produce 2 moles of water vapor. So, in fact, I can do that. That's pretty easy. If I don't forget, okay. Oh, why am I doing so badly? There we go. So I have 2 moles of H2 gas, and again, I suck because I didn't write moles. Okay, to every 2 moles of H2O. And obviously, if it's a 1-to-1 ratio, that's not going to change anything. That's going to give me, I can do this math in my head even, 0.52086 moles of water will be produced. And I'm going to circle that in purple. And I'm going to compare those two numbers. So if I had 0.038126 moles of oxygen, I would produce this amount of water. Okay, and that would be with an unlimited amount of hydrogen gas. If I had an unlimited amount of oxygen, but I had this much hydrogen gas, this is how much I produce of water. Now notice how much bigger my mole value is in this case down here for my hydrogen. That's important because that helps us to determine that the limiting factor is actually this dude. The limiting factor is always the compound or the molecule that's going to produce the least amount of product. Just like when we go back to my matching up outfits for Chang and laying them out on his bed, it's going to be the item that's going to produce the least number of complete outfits. In that case, it was sweater vest. In this case, it happens to be oxygen. All right? So the limiting factor in this situation, despite the fact that there are more grams of oxygen, it is the limiting factor in the process of making water. Okay, goodbye.